Welcome back, children. Today in this module we are going to discuss about the remaining periodicity of the properties of element. So before I start, I want to recapitulate what I have taught in the previous module. So in the previous module we have discussed about the properties called as valency and atomic size. I think I have also done metallic character. So first of all, before I move to that, recapitulation is very important. So in case of valency, as I have told you that as we move from top to bottom down the group, the valence electrons remain same. So here the valence electron is 1, here also the valence electron is 1. Okay, so this is about one particular group. Again, if I'm moving to this, here I'm having the valence electron 2, here also the valence electron 2. That means as we move from top to bottom, the valence electrons remain same. But as we move from left to right across the period, the valence electron increases. Okay, so with the help of an example, it will be quite easy for you people to understand. The next is what? Atomic size. Now pay attention, children. Here, as we move top to bottom down the group, the first thing that we see is that the atomic number increases. Here the atomic number is 11, here the atomic number is what? 19. So the atomic number increases. So as a result of which you can see that in the electronic configuration we are having 281, and in this electronic configuration we have having 2881. So in this you can see that we are having how many cells, children? Tell me. 3 cells, and in this we are having what? 4 cells. So as a result of which, what will happen? Tell me. If the number of cells will be increasing, that means what? The size will be also increasing. So the atomic size increases. But remember one thing, children, if the atomic size increases, as a result of which we can also say that the nuclear force of attraction also decreases. Again, I am repeating, when the atomic size increases, the nuclear force of attraction decreases. Keep in your mind this one. Okay, next, if we move from left to right across the period. So from this it is very clear that as we move from top to bottom, the atomic size what? Atomic size increases. Now let us take the example of the sodium and magnesium. Here also you can see that as we move from left to right across the period, the atomic number increases. Here it is 11, in the next it is what? 12. But the important thing is that here the number of protons increases. I'll say number of protons increases here, but this is number of electrons. So number of electron 1, and as a result of which here you can see that the number of electron is 2. So as a result of which the effective nuclear charge is going to increase, and because of that the nucleus will be having a greater pull to the electron. So the electrons will be pulled towards the center of the nucleus, and as a result of which the size is going to decrease. So as we move from left to right across the period, the atomic size decreases, and as we move from top to bottom, the atomic size increases. The next comes metallic character. Metallic character means what? Tendency to lose electron. So children, you can see one thing here, that in this case what is happening? It is having 1 electron and it is also having 1 electron, but the number of cells increases. But I have told you what? As the number of cells increases, what is going to happen? The nuclear force of attraction decreases. Now nuclear force of attraction decreases, which means in this the nuclear force of attraction is greater, and in this it is what? Lesser. So which one will be comfortable to lose electron? This one. Why? Because it is having less nuclear force of attraction. So from this it is very clear that as we move from top to bottom, the tendency to lose electron increases. Why? Because the nuclear pull is decreasing. Is it clear or not? So as a result of which element can easily lose the electrons in the outermost orbit. So we can say that the metallic character is going to decrease, and here the reverse will be happening. So the metallic character will be increasing as we move from left to right across the period. Now the rest of the variations, what I'm going to discuss, in all the variation, children, the same thing will be there. What are the thing? What the same thing I'm talking about? It means what? As we move from top to bottom, the ionization potential, what happens? The ionization potential decreases. As we move from top to bottom, the electron affinity decreases. As we move from top to bottom, the electronegativity decreases, and as we move from left to right across the period, the same all will be increasing. And the same reason you are going to write down. I am explaining. So like take the example of ionization potential. I have told you what is ionization potential, the amount of the energy required to remove the most loosely bound electron present in the outermost orbit to form a neutral gaseous positive ion. Take the same concept. Here in this case there is a strong force of attraction. That means we need more energy to remove this electron from the outermost orbit. But in this case what is happening? The number of cells are getting increased. So as a result of which the nuclear pull will be less, and in this case comparatively we have to apply less energy as we have applied in this one. So here we can see that as we move from top to bottom, the IP decreases, and just here the nuclear pull increases, so we can simply say effective nuclear charge. So as a result of which you can say that the ionization potential increases as we move from left to right. The same applies to what? Atomic ionization, electronegativity as well as electron affinity. Am I clear, children? Now, one very important thing, whenever you are doing the periodicity variation, keep in your mind that there are exceptionals of noble gas in case of electron affinity and electron negativity. Again, I am repeating, whenever you are discussing about the variation of electron affinity and electron negativity, in that case you are not going to consider the noble elements. Like if somebody asks you which is the highest electronegativity element, so in that case you are going to move to the halogen group to be considered to be the last one, not the noble elements. Is it clear or not? Understood or not? So based on this topics, you can say based these variations, the next module in that we are going to you can say do the periodicity. Like I'll give you 5 or 6 elements, and it will be asked to arrange the elements in the increasing order of atomic radius or ionization potential or electron affinity. Till then, you keep in your mind one very important table. What table I am talking about? You are going to write here what, like this: valency. Okay, or valence electrons, like this, valence electrons. Then you are going to write here what? Valence electron. The next will be what? Atomic size. The next will be like this. You have to make a table. That will be your assignment or homework. Atomic size. Next you are going to write here metallic character. Next you can write ionization potential, electronegativity, electron affinity, and then you are going to write here one thing which is called as what? Down the group. So this will be equals to what? Down the group. So when you write down the group, that means I am talking about top to bottom, and here you are going to write here across the period. So when I say across the period, that means we are talking about left to right. Is it clear? Now accordingly, valence electron down the group remains same. So you are going to make the table for all the, you can say, properties remains same. In this case, the atomic valence electron across the period increases. Here in case of atomic size, we have discussed that what? As we move from top to bottom, the atomic size increases, and across the period, the atomic size decreases. So this table you prepare and just keep in your mind. In the next module, we are going to do the, you can say, variations in which the elements will be provided, and you will be asked to arrange the elements according to the given properties. Thank you all of you.